What's going on, guys? We've got the O2 Mustang in here again. Today we're going to be talking about when OBD diagnostics fail. So typically what you'll get as a technician or a mechanic in the industry, you'll get a running rough and no code set. Check engine light is not on. All your OBD2 monitors are passing and no codes are setting, but it's absolutely running like garbage. You're driving it and it's just running like crap. These can be very difficult to figure out. I typically like to approach these from a different mindset. I like to kind of change my perspective, kind of, wash out any preconceived notions. There's some, very basic things that need to be checked. Some simple tests that can be run to determine, where the issue is, where the issue resides. Is it a vacuum leak, an exhaust leak, a fuel issue? Is it an intake issue? Any of it, a thousand things can cause an issue running wise with an engine, and a lot of times ECM can't catch these failures. So what we're going to be going over is running rough, no code set. So right here I've got a little bit of a list, some stuff to kind of keep me on track. This is about the 6th time I've tried to make this video, and I keep going off on tangents. So we're going to try to keep this as much on topic here as possible. So when the OBD2 system fails, OBD2 stands for onboard diagnostics. Now, OBD2 was instigated and mandated in '96 is when most vehicles were mandated to this. So anything pre-OBD, 96, you're going to be bending a paper clip and jamming it into the OBD2 1 port in the right terminals, and then actually counting the flashing light. Very old school way of doing it. I hope none of you guys are messing with those. If you are, good luck. They're not fun. But a lot of those OBD1 systems were not able, they didn't have a whole lot of codes that they could even set when they saw an issue. So you see a lot more of this in OBD1. Anything pre-emission stuff, so pre-80s is going to be no ECM, no computers. Everything's mechanical, and that's the kind of diagnostics that we're going to be doing today, not necessarily, a failed engine or low compression. It very well could be one of those issues, but we're going to go over that, and I apologize for my handwriting, but we're going to get into this real quick. So we're going to start with, we're talking modern fuel injection vehicles. This one, that's a 2013 Infiniti. It's going to have a lot more intelligent, a lot more control modules, a lot more systems that it's monitoring, where a lot of those systems didn't even exist back here on this O2 Mustang, and it gets even worse the further you go back, like my 94 Chevy I've got parked outside over here. That one has OBD1, and it is absolute garbage as far as throwing codes. It just won't. You just have to know things to test and things to check in order to get it diagnosed, figured out, and repaired, and roadworthy again. So a lot of you guys are going to be working on OBD2 systems, anything post 96, and this is where we really start to get into the issues. And the newer the vehicle is, the less likely it is going to have these problems. However, I have seen OBD2 issues where they won't set a code and it's running like absolute crap on as new as 2020, 2021 vehicles. I mean, this kind of an issue does happen. And if you are in this kind of a situation, I'm sorry. Please comment below what your issue is. I might be able to help you out with it. So when the OBD2 system works, and of course now my camera, for whatever reason, doesn't want to read this. There we go. When it works, so it'll set a code, P0171, which is lean bank 1, meaning the engine is not getting enough fuel on bank 1 in order to meet its emission requirements, meaning we're running too lean. We risk doing damage to the engine. If it runs too lean, you do run the potential of blowing holes in pistons, especially at wide open throttle. So this is definitely a bad one to have. However, typically these can be resolved fairly easily. But what it means is that we've got some sort of an issue. It doesn't tell us specifically what, but we have to diagnose it. Now, if we have all data or an electronic service manual or an old paper service manual, anything that can kind of give us, a list, and typically they will give you tests to run in order of check this, now go check this, now go check this, check this, check this. This is what you should be seeing here. Just run through all these tests. So I don't have an ESM in front of me, but generally they're going to go somewhere along the order of this. Now this listening is a very big one. This can help out a ton. What you want to do is pop the hood, start the engine, and listen. Do we have a vacuum leak? If there's a vacuum leak, you'll hear a whistle or a sucking sound. Okay, and this can be very easily tested. A vacuum leak, we can either a can of starting fluid and spray it over the top of the intake the intake tube coming up to the manifold itself, vacuum lines going into the manifold, and if you get a change in the way the engine is running when you're spraying that on it, you know you've got a vacuum leak and you can locate it fairly easily. Also, listening and using your finger to trace along the wire to try to find a vacuum leak. You can also listen for it and hunt it down, and then when you plug it off, it'll go and it'll shut up. And typically when that happens, the engine will accelerate and it will run significantly better. You'll take your finger off and it runs like crap. Put your finger on it and it runs excellent. But that's for vacuum leaks. Now, if we're hearing a puffing noise at idle, typically it's an exhaust leak. Now, these are very easy to test as well. Typically, I like to have a second set of hands. Better to be up on the hoist, but what you want to do is take a fistful of rags and typically a nice sturdy leather glove. I prefer a welding glove, especially if they're a lube tech or kind of a less experienced individual helping you with this. That way you can reduce burns on them. But the easiest and quickest way is just to take your hand, plug the exhaust, and feel if it's building pressure. If it builds pressure and you take your hand off and it goes and releases, you know you've got a sealed exhaust system. But if you plug it up and it's building a little bit of pressure, but you can hear a puffing noise upstream, you know you've got an exhaust leak. Now, the best way to track down an exhaust leak is to, one, either be on a hoist or have the vehicle jacked up in the air, especially if it's a lowered vehicle or low to the ground already. Jack it up and then start it, preferably cold. Cold is the best way because once it gets hot, it's going to burn you. Plug off the exhaust, reach around and feel around the exhaust. What you're feeling for is hot puffing air. Now, this is obviously the intake, but very similar. Typically, you're going to see problems near the welds, not in the straight pipe. However, I have seen, pipes will rot out in a number of thousands of places, especially if it's got water flipping on it from the wheels. But what you're looking for is an exhaust leak, either by the Y pipe, where the exhaust pipes come together ahead of the oxygen sensors, or behind the oxygen sensors. And you don't want any leaks behind or in front of the catalytic converter or within about 2 to 3 feet of that oxygen sensor, that rear oxygen sensor, because what that will do, even a pinhole will allow air into the system and will throw off your oxygen sensor and make it compensate for either a lean or rich condition when there actually isn't one. It's actually running just fine, but because of that air that's hitting that oxygen sensor, now that oxygen sensor is skewing the readings on the engine and making the engine add additional fuel, trying to get rid of that pinhole leak that's pulling air into the system. Things to be aware of that can cause issues. So, OBD2 system's working. It's set a P0171. I'm going to try to speed this up here a little bit. We're listening for either a whistling noise or a puffing noise before the O2 sensor within 3 feet of the O2 sensor. So if it's above the O2 sensor, it's not good at all. And by up, I mean upstream of the oxygen sensor. Anything behind the oxygen sensor, if we have a pinhole within 3 feet, because of the reversion that occurs inside of the engine, meaning as that piston is coming up and pushing out that exhaust, it will actually start to come back down and create a vacuum and actually pull some of that exhaust gas back into the engine before that valve shuts completely, the exhaust valve, and before that intake valve opens, or sometimes it's called overlap, where we'll actually have, briefly, we will have both the intake and exhaust valves open, and that will allow air to travel back up the exhaust pipes and back up to the engine. We don't want that. So, now, there are definitely some benefits to valve overlap, but knowing that is why the engine can skew because of the oxygen sensor reading, because we have a pinhole vacuum or a pinhole exhaust leak that's pulling air back up. So, we ran those tests, we listened, we checked the exhaust for leaks, didn't find any leaks. Now with the intake, there are a number of things we can do. We'll come over here real quick. We can, if we have a vacuum leak, we can use a vacuum gauge. Typically you want to see about 21 inches of vacuum. If you're in a shop, hopefully you have access to what's called a smoke machine, where you'll actually plug off the intake port, hook up a smoke nozzle, turn on the machine, and it will actually fill the entire intake tract, the entire intake system with a smoke that it generates from overheating oil that's internal to the machine, and then it will fill the entire intake system up full of smoke. Now, typically you'll plug off the intake, preferably right after the air filter, so that you can test all of the intake system coming up to the manifold. But what that will do is that will pressurize the system, and anywhere that there's any kind of a vacuum leak, it will spray smoke out of it. Usually a very quick, easy way to determine whether or not we have a vacuum leak. So we can do that to test for a vacuum leak. So we'll say we ran these tests, we hooked up a vacuum gauge, had 21 inches of vacuum. That's good vacuum. We're not hearing a whistling noise. We don't have an exhaust leak, so we're all good there. So right here, no vacuum leaks, no exhaust leaks. Well, we got a P701, so the service manual or all data tells us, okay, next we need to run a fuel pressure and quality test. Now, typically they'll say pressure test. I'm adding quality because anytime you disconnect a fuel line, you're going to get some of that fuel sprayed on you. And you can always kind of get a whiff of it, a smell of it, whether you want to or not. You're typically going to get a whiff of it, but just see what it smells like. I mean, don't necessarily sit there and huff fumes, but get a sense of what the fuel smells like. And you should know what good fuel smells like. I'm sure any of you have filled up a lawnmower, or even filled up your own car. You get a whiff of that, unburned fuel, that rich fuel, just that potent. Whoa. But that's what you want. If it smells rotten, if it smells like garbage, or it smells like diesel, I've had that before, or any other kind of contaminant, or it's full of water, then we know that we have a fuel issue. We know that we've got garbage fuel. The engine doesn't want to run on it. Sometimes you need to get an external fuel source, like putting some, draining the tank, putting some better fuel in it. A lot of times that can correct the issue. So fuel pressure and quality test. So we smelled the fuel. It smelled pretty potent, smelled rich. We're not concerned with that. And again, this is all hypothetical, but we're going to go ahead. Good potent fuel. Excellent. We're going to run a fuel pressure test. We only getting 21 PSI at idle, and the spec is 40 PSI all the time. That's idle. That's under hard load. That's wide open throttle. But we've only got 21 PSI at idle. So now we know that we have a fuel issue for sure. No way around it. We got a fuel issue with a PSI like that. And there are a number of things that can do it, a number of things that need to be tested. So fuel pressure regulator, this is FPDM. Fuel pressure driver module, a fuel pump and filter, and that is very possible that it is just a fuel pump and filter. And what it would come down to is knowing how the system is supposed to work. So is it a single system, single fuel line system or a returnless system, meaning there's only one fuel line coming from the pump and filter internal to the tank, coming all the way up to the injectors, or all the way up to the fuel rail, and there's no return line coming back to the tank. That would be a returnless style system, where a return style system will have its own special pressure regulator that will actually regulate. So when the fuel pump, and typically they are on-off fuel pumps, whereas and I'm getting a little off tangent here. I don't want to go too far out, but for purposes, this is a returnless style fuel system, so we have no fuel pressure regulator to worry about. We're not concerned with the fuel pump driver module. All we're going to do is go back to the fuel pump and run a voltage test. Now we get to the fuel pump, we find we have 12 volts. We've only got 21 PSI at idle. More than likely it's a failed fuel pump. Now it very well could be a plugged fuel filter. And if you are on a budget or trying to fix this as cheaply as possible, that would definitely be the place to start. Replace the filter, blow through it. Make sure when you pull the old one out, blow through it. And if you can blow, now you don't want to suck through it. You don't want to suck that fuel and all that nasty crap into you. You want to blow through it both directions. Typically, you want to blow the way the fuel line is headed up to the engine. That way you can see if it's plugged up. And if you're having to puff through it really, really hard and blowing really hard and barely anything's coming out, it could be as simple as replacing that fuel filter. Now, as a technician in the industry, I'm going to go fuel pump and fuel filter. If I've got good pressure to the pump, always a good idea to replace the filter at the same time, because it might not have been the pump, could have been the filter. However, I'm typically going to say more than likely it's a failed fuel pump on most modern vehicles. So now something like this O2 Mustang, I would absolutely recommend to the customer that we start with a filter. However, on something like that brand new Infiniti, this is Krieger, this is my chocolate lab. He is hot and sweating his butt off, so he's in here hiding in the garage. But something like this Infiniti, there is no external fuel filter. The fuel filter is the sock on the end of the pump inside of the tank. So if we have a fuel pressure issue, there's no regulator. on this one. All it has is injectors, a fuel rail that runs all the way back to the tank, and a pump with a sock on the end of it. That's all there is to it. Now, the pump is controlled by its own fuel pump driver module that can vary the amount of fuel pressure coming up to the engine, but if I've got good voltage back to the pump and I've only got 21 PSI, I know I'm replacing a fuel pump in something like a Nissan or this Infiniti. That's where I'm going. Where something like this, where it has an external fuel filter, I would definitely test the fuel filter before replacing it, but a lot of times it's better off just to start by replacing it, especially with a customer, especially if we're into it about an hour. Say, hey, we've got a fuel pressure issue. It could be the pump. Let's start as cheaply as possible with the filter. We'll replace the filter and then go from there. And if the filter doesn't correct our fuel pressure issue and clear the P0171, then we need to do a pump. Now, a lot of people are going to say, screw that. Let's just put a pump and filter in it and be done with the entire fuel system. That way we know we have the maintenance done and we have a good fresh fuel pump. Let's start with that. So, an issue like that, okay, where the OBD2 system works, we can come to a conclusion based on logical processes and diagnostic tests. Now, when the OBD2 system fails and it's not setting any codes, and all the emission monitors are saying, hey, we are good to go, we are emission compliant, everything is A-okay. However, car runs like crap. Customers been to 3-4 different shops. No one's been able to figure this out. Can you take a look at this? So, yeah, we'll take a look at it. We'll see what we can come up with. So the easiest ways to start are simply clear your head, okay? Take all the preconceived notions, all the preconceived BS. It's not throwing a MAF code. It's not throwing fuel pressure codes. It's not throwing lean codes. It's not throwing rich codes or any of 1,000. It's not throwing EGR flow codes. I mean, it's not doing anything. It's just running like crap. So very first thing we would want to do, and I know I have this second on the list, is maintenance items. What's going on maintenance-wise? What's the air filter look like? And I cannot even begin to explain the amount of times I have seen a car come in like this, where it's been to 3-4 other shops. One shop recommended it needs a transmission. You know, one shop was saying, oh, it needs spark plugs. The customer refused. He just put spark plugs in it 100 miles ago. They bring it to me. I check the air filter. It's plugged solid. And by plugged, I mean I can take a very bright flashlight, try to shine it through it, and I'm not seeing any of that incredibly bright light coming through that filter. That son of a bitch is plugged up. Replace it. Throw it in the garbage and get a new one. And I have seen that correct so many cars, and a lot of the time I'll refuse, you know, to charge the customer diagnostics for that. And a lot of times when I do that, I'll earn that customer for life. They come back to my dealership and they ask for me by name because they had a shop, you know, another dealership 2 cities away that told them, oh no, you need a transmission. They brought it to me. I went and drove it, and I went, well, it doesn't really seem like it's accelerating all that well. It seems like it's more of an engine problem. Pull the air filter out. It's plugged solid. You need an air filter. That'll be $20. Install an air filter for them. Runs like a champ. No issues, no problems. A-okay, good to go. Now, if the air filter check's good, okay. Now, this is where the most amount of information you can gain, the better off you're going to be. Ask them, you know, okay, when was the last time you did plugs and wires? Oh, well, 2 dealerships down the road just did plugs and wires, and ever since they did spark plugs and wires, it's been running a lot worse. Or, you know, it seemed like it was running a little better, but the problem was still there. You know, it might be worth pulling a spark plug and just looking at it to see what's going on. Now, I have seen that a lot of times where they've got a running issue and it's running like crap, and they decided to throw spark plugs and wires at it, okay? And then all of a sudden it won't even start, or it's running worse than it ever was before. And so they limp it down to me, or they tow it to me and said, well, we just put plugs and wires in it. Now it's running worse than ever. It had a running issue, so we replaced plugs and wires, just tried to do our own maintenance items. And I go, okay, so I'm going to double check their work. I'm going to check the plug wire routing, you know, if it's old enough. Now, something like that has individual coils per plug, where all you'd want to do is check that the ignition coil plugs are plugged in where they need to be. And they haven't gotten 2 and mixed them up and plugged them in backwards, so it's getting spark at the wrong time, and it's just running like absolute garbage. On something older like this, you would want to double check their spark plug wire routing and make sure that all the plug wires went back to the same spot. If they did, you're A-okay there. Pull a plug, look at the plug. Now, a lot of the times when I've had this come in, What it is on the end of the threads, they put some type of an anti-seize on them to prevent the plugs from seizing. Now, AutoZone recommended it. They charged them $1.25 for a little packet of it. They ended up buying 3 of them and coated the entire threads in that anti-seize. Well, the problem is that anti-seize, albeit copper or that aluminum paste-looking stuff, it does not conduct electricity. So the spark plug is getting spark. It's getting the voltage from the coil all the way to the spark plug, but because it can't ground back to the engine block, it can't fire. Something like that, as simple as pulling out the spark plugs, taking some either starting fluid or carb cleaner, blasting out the plug holes to wash all that anti-seize. Now, preferably it's better to wipe it out, but a lot of those holes are inaccessible. Better to just kind of hit it with just a little bit, blast them, clean them up a little bit, pull out the spark plugs, make sure that they didn't get anti-seize on the contact points on either the arcing arm, and I forget what they're called, but or the actual contact coming out of the center of the spark plug. Make sure there's none up there. If there's none up there, it can be reused. Just take some brake clean, spray it on a rag, and wipe all that anti-seize off the threads. Put the plug back in. I have fixed so many cars that way simply by a customer not knowing that that anti-seize crap that they sell at AutoZone doesn't conduct electricity. And they cover the entire grounding portion of that spark plug where it grounds to the cylinder head in that anti-seize, and now it can't get voltage through the spark plug, so it can't have any spark occur. One of those things to check. So I'll pull a spark plug, and we'll say, for example, this time, they all look good. I checked the gap on them, I verify the gap. All the gap's good on all the spark plugs. Plug wires went in where they need to be. It's not a spark plug issue, but we're still checking maintenance items. Air filter, spark plugs and wires, PCV valve. Has the fuel filter been replaced? And this is some stuff you can ask the customer. Have you done a PCV valve lately? Have you done a fuel filter lately? And there are some simple tests to verify PCV valve operation. Fuel filter, we'd want to run a fuel pressure check as we did over here. A PCV valve, preferably you have some type of access to the OBD2 system, meaning some type of scan tool that can monitor the live data. The information that the sensors on the engine are sending to the ECM. A lot of times we can read those. Typically a very cheap scan tool as low as $100 usually will allow you to read that. In a shop environment setting where I work for Nissan, I have what's called a factory scan tool that I can actually see just about everything. And I can't see all of it, every single sensor coming into the ECM, but I can see a lot of them, and that's typically where I like to go. So we know we don't have a vacuum leak. We're not hearing a vacuum leak. We know we don't have an exhaust leak. Maintenance-wise, the air filter's been replaced, spark plugs and wires have been replaced, PCV valve, let's say, has been replaced, the fuel filter's been replaced. We verified the spark plugs and wires to make sure they didn't screw anything up. Now with an air filter replacement, if the customer has done it, or if another shop has done it, one of the common things to look at is a mass airflow sensor. If you can gain access to it readily, so something on like this V6 Mustang, the stock MAF sensor, it's going to take you about an hour to tear down to it, even to unplug it and pull it out to the entire airbox assembly, to disassemble that entire airbox assembly and carefully, without breaking it, pull out the MAF sensor to inspect it, can be incredibly difficult. However, on something like a much newer Ford or on this Infiniti, it actually has a MAF sensor with 2 bolts that go right into the side of the intake, and you just 1-2 bolts, pull it right out, and look down inside of those wires. And I apologize, I don't have a MAF sensor here at home. I do have quite a few spares at the shop where I could show you, but what you want to do is look down inside of the port and see if you can see the metal wires down in there. And what you're looking for is any kind of fuzzies, any kind of debris. Typically, the most common that I see is somebody ran the engine without the air filter, or the filter failed and allowed like a dandelion seed to get sucked up on the intake air temperature or the MAF sensor hot wire. And that is skewing the air-fuel ratio so wicked bad, it's throwing off the mat that the engine's running like crap, but the ECM is not seeing the issue. Simply inspecting a MAF sensor to see if it's contaminated. Now, you can clean them sometimes. I don't recommend it. I recommend replacement simply because I've cleaned many of them and had them come right back with the same issue, end up replacing the MAF sensor like I initially recommended, and everything's A-okay. Customer comes back in 3,000 miles later for an oil change, check engine light stayed off. Customer comes back 6 more times to do oil changes, basic maintenance items, and they never have an issue with that MAF sensor again. so long as the air leak issue was resolved, let's say we had a bad filter, if they didn't replace it, I mean, that's just going to continue to cause issues. So you have to kind of, kill the root issue of the cause, which the root issue of that cause was a leak allowing a dandelion seed to blow into the mass airflow sensor. I have also seen mosquitoes get sucked in there and melt to the intake air temperature sensor. I had one of those this week. I've seen flies, dragonflies, damselflies, all kinds of stuff can get plugged up on those MAF sensors. I even had one, it wasn't actually the MAF sensor that was having issues, but I went to inspect it, pulled out the MAF sensor, was looking at it, I'm like, oh, that all looks fine, set it aside and looked down the intake tube, and all I seen was a big thing of ball of fur, and I was like, well, that's not supposed to be there. So I reached up that intake tube with a pair of pliers and grabbed it and pulled a dead squirrel out of the intake tube. The car wouldn't throw codes. It was running like crap. It intermittently would run just fine, and then all of a sudden it would just start running like crap. But what was happening is that squirrel was getting sucked up and down the intake and plugging it up, and then all of a sudden the car would run like crap. You'd get out of it, you'd let off the throttle and coast down, and then it was like the squirrel would kind of fall down the intake tube a little bit, and then you would have power again for a while until you got on it too hard. Then it would suck that squirrel back up and plug up. I've seen some crazy stuff. So general maintenance items, always a good thing to check. Check your intake tube, make sure the engine is even able to breathe, make sure the throttle blades are working properly, that the throttle isn't sticking. On something older like this, where it just has a throttle position sensor on it, you're A-okay to open up that throttle blade, inspect behind it, check for carbon, pull it out, clean it all up, and you'll never not have an issue. However, on something like this, where it actually has electronic throttle control, you do not ever, ever, ever want to open that while the connectors are plugged in to the throttle body, because they have electric motors inside. And if you open that throttle body with those electric motors in there, what they'll do is when you open that throttle body is they'll actually generate a voltage, and that voltage will go right down the lines all the way back up to the ECM, and it will fry the engine.